So what if you're ever asked to use algebra and solve this algebraically? Whew, well, boy, oh boy, okay, let's figure this out. Well, before we can even solve this algebraically, yep, look what we got to deal with again. What are the restrictions? So let's take a look at the restrictions first. Here's this guy. A minus 1, we all know that it has to be greater than 0. Bring the 1 over. A has got to be greater or equal to 1. Perfect. There's one of the restrictions. Now look at this guy. 3a minus 5 has got to be greater or equal to 0. Bring the 5 over. Divide by 3, divide by 3. Kind of gives you a nice fractional 1. But the thing that you have to realize is on a number line, this is almost 2, right? That is 1. So let's take a look at our number line and let's go check it out. Let's plot it in there. Sheep, sheep. There we go. There's 1. There is 5/3. There's about 2. Okay, so we said on this one has to be greater or equal to 1. So greater or equal to 1 is got to be that way. And then we look over here and say, greater than or equal to 5/3, and there's our double shade. So that means this is the only restriction that you need to put. That one works for this guy, but it won't work for that. Okay, so that's what we have to be very, very, very cognizant of. That's the actual restriction. So I'm going to put that restriction up in the corner here, greater or equal to 5/3, and now erase the rest of this, and let's go to town. If we have to solve algebraically, before I even solve it, I do this and I'm your teacher and I know how to do this and I'm pretty smart at this. What I do first is I check out the answer on my calculator and I use my calculated answer as my guide. Okay, and you'll see why in a second. So I'm going to make this guy a little bit more calculator friendly. I'm going to take this guy and I'm going to move him over to the other side. So I'm going to go square root of a minus 1 equals to 2 subtract the square root of 3a minus 5. And you know and I know when you use a calculator, put that as y1, put that whole thing as y2, and you'll see. So I'm going to boot up my calculator right now. There's my y1. I'm going to put my second square root of my x, because I don't have a's on this, x minus 1. Boot down to here, and I know my other one is going to be 2 subtract the second square root of 3x minus 5. Okay. When I do that and I graph this, I get something that looks like this. There's my intersection point, but I'm curious as to what that intersection point is. It looks like it's around 2, so let's go try and find it. Second calc, let's find that intersect, 5, mouse over. Now remember, when you see something like this, and there's no y value, and there's no star on this graph, that means you're not close enough to it. Get close to 2. Move this guy over until you're over close to 2. Look how those x's are changing, and suddenly it appears. Look at that. The little star appears. Hit enter, and that automatically boots to the second curve that's also just below it. Hit enter, yes, guess, and look what you got. You got an x equaling to 2. Remember, the y you don't care about because there is no y in the original equation. So you know the answer for this is going to be x equals to 2. So okay, I'm going to put that up here. I'm going to know my answer is a equals to 2, and I'm going to use that as a guide. Now, we're at this point right here. Oh, baby, your algebra better be just incredibly sharp at this point, because this is what it takes. All right, so first thing you're going to do is you're going to square both sides. So this side's pretty nice to square, but look how ugly that one is to square. Oh my goodness. Okay, so don't worry about it. Let's just go. The square of this side is very simple. This is just going to give you a minus 1. Okay? Now, the square of this side, this is a binomial. So in order to square this properly, you have to go 2 minus root 3a minus 5 times 2 minus root 3a minus 5. Oh my goodness, that's going to make things really, really, really interesting. Okay, so let's keep on going then. This side, nothing to do. A minus 1, let it just be a minus 1. Here comes the FOIL. Whoop! Oh, boom, 2 times 2. Oh, that's really tough. Okay, that's going to be 2 of these guys. That's going to be 2 of these guys. So we actually, if you figure it out, you have 2 root 3a minus 5 minus 2 root 3a minus 5, which are like terms which you can combine right away. And then multiply these guys out. Well, root times the root gives you, guess what? Well, negative times the negative makes it a positive. This guy, which is exactly the same as this guy, it's just like saying squared, get rid of the radical sign. So this becomes 3a minus 5. Wow. Gosh, look at this mess. That's not that bad. Scale of 1 to 10, I would say it's about an 8. Yeah, let's see what we can do. Here's our a minus 1 still sitting out there all nice and lonely. Now, let's go out and combine some like terms. Look at that. Combine these guys. What do you have? You got 4 and minus 5. That works out to be minus 1. You got a 3a out here. Okay, plus 3a. Whoopee-doo. You've got a minus 2 square root 3a minus 5 and another minus 2 square root 3a minus 5. So it's minus 4 square root 3a minus 5. Combine like terms. Okay, well, this ain't so bad. Now, let's start looking at a couple other things here. Let's start throwing a whole bunch of stuff together and see what we got. Let's combine everything. Well, let's work with this side. Get rid of the a. Oh, okay, well, that's pretty. Look what you get. That cancels, leaving you minus 1 equals to minus 1. 3a minus a is positive 2a minus 4 square root 3a minus 5. Oh, looks awful still, right? Not really. It's getting better. It's actually getting better. Watch this. Add 1 here. Add 1 here. Oh my gotcha. This is gone, and so is that guy. So this is now 0 equaling to 2a minus 4 square root 3a minus 5. Look how that cleans up so pretty. Oh my goodness. Okay, now watch this. I'm going to add 4 square root 3a minus 5 to both sides. And the reason why is because I want to isolate the radical so I can solve it. Okay, so that cancels here. That's gone, leaving you 2a on this side, equaling to 4 square root 3a minus 5. Okay, all right, we're going. We're getting there. Let's keep on going here. Let's see what we can do now. I would divide each side by 4. Yuck. This is going to give you square root of 3a minus 5 equals to, well, 2 over 4 is a half. A. Oh, that's not so bad. Now, solve it by squaring this. So you actually have to square twice. Oh my goodness, isn't that interesting? Well, yeah, you had 2 radicals, so you got to square twice. What's 1/2 a all squared? 1/4 a squared. Beautiful. Now, I want to get rid of that quarter because I think that is just plain ugly. So I'm going to multiply both sides by 4. I'm going to do that right now. Get rid of that, get rid of that. That gives me a squared equals to, distribute this. I have 12a minus 20. Look what I'm getting. Oh my goodness, look what I'm getting. Look what I'm getting. Oh, this is beautiful. Subtract the 12a, and I'm going to add the 20 to both sides. Subtract the 12a and add the 20. Look what I get. That cancels, so giving you 0. This is a squared minus 12a plus 20. I have a trinomial. Beautiful. PSA, baby. 20 here, minus 12 there. 2 numbers is minus 2 and minus 10 because they work. Oh, look how gorgeous this is turning out. This is giving me an a minus 2 and an a minus 10 equals to 0. Solve. A can equal to 2 or a could equal to 10. Now, is one of them extraneous? Of course one of them is extraneous, because if you remember at the beginning of this entire mess, all the way back up here, we solved this on our calculator and said a equals to 2. So 10 has to be extraneous. Well, I want to prove that. I want to prove that right now. I want to prove that 10 not gonna work. All right. So put a 10 in here. Watch. 10 minus 1 square root is 10 minus 1 is 9. Square root of 9, that's easy enough to do. That's 3. Beautiful. Plus, okay, so I'm going to do a plus here. I'm going to put the 10 in here. Okay, 10 times 3 minus 5. Okay, 10 times 3 is 30. 30 minus 5 is 25. Oh, look at that. Look how pretty. It seems to be working out now. Square root of 25 is 5. 3 plus 5 together then has to equal to 8. Perfect. That equals to 8. So this side is now complete. But look what it has to equal to. It has to equal to 2. And guess what? It doesn't equal, meaning that A equals to 10 is extraneous. It's not going to work. And that's how you solve questions like this algebraically. Woo!